Hello dear friends, welcome to Gate Academy Global. So before starting today's session, I would like to take the concurrence or the feedback from each one of you regarding the quality of video as well as audio. If it is perfect, just type perfect over the live chat and then we are ready to go. Anyways, the agenda behind today's video is very precise and clear. Already this thumbnail has been posted over our Telegram group as well as channel, and at the same time it is clearly visible over the YouTube thumbnail. Yes, we already had the 3 number of videos over the sequence of the videos which were designed for the engineering mathematics, and I was taking the previous year questions from few of the important PSUs as well as government examinations, which I was including ISRO. I was taking care of the engineering services examination, even I was taking care of the BARC examination. Yes, so the student who have been following me definitely they know about this. Already the 3 video has been over this series, and now I would be taking the 4th video over this session. So what I would be doing, without getting delayed, let me straight away hop into the questions which we are going to take in today's video. My dear friends, probably I would be taking 6 to 7 number of questions which have appeared in previous year examinations, including ESE common to all, including ESE specific to the electrical. So whenever I would be taking the problem, specifically I would be mentioning whether the problem which I am going to take or the problem which I am going to solve now has come into common to all paper, or whether it has been specifically come into the electrical paper. Why I am saying specifically for the electrical paper? Because in ESE, once you will go through its syllabus, within the ESE, within the technical segment, even the engineering mathematics do lie for the electrical engineering. Agreed? So without getting delayed, let me straight away jump into the first question. Anyways, let me read the problem carefully and then we'll try to smash this problem out. What the problem states: find the absolute maximum and minimum values of f of xy is equals to of minus 2 plus of 2x plus of 2y minus of x square minus of y square on triangular plate in the first quadrant bounded by the line x is equals to 0, y is equals to 0, y is equals to of 9 minus x. So what I would be doing at very beginning, I would be taking its screenshot and will bring it to the working board. So I would be taking its screenshot and will be bringing it to the working board. So here goes the problem. Anyways, once you will read this problem carefully, you yourself would be able to judge. It's a problem where the function involves the 2 number of independent variables. How did we know about it? See, the first point, you yourself would be able to judge. The f was the function of x and y. That's the first thing. Secondly, once you'll see this function carefully, you'll understand there are 2 different variables are getting involved within the function of f. So obviously, whenever you have this sort of problem, that means you are going to deal with the concept of maxima and minima for sure. Yes sir, we are going to deal with the concept of maxima and minima. But it is bivariate independent function. That means 2 number of independent variables are getting involved within this function. And once you read this problem carefully, you will get to know they have been seeking for the maxima and minima of the function. Within a certain predefined range. May you know what is that range? The range has been clearly written. You had to find the value of maximum worth or the minimum worth of the f of x, y within the range which has been bounded by x is equals to 0. May I know what does it mean by the x is equals to 0? So if you take the reference of xy plane, x is equals to 0 is nothing but the y axis. Similarly, y is equals to 0. If you take the reference of xy plane, y is equals to 0 is nothing but the x axis itself, and here goes the another line over the xy plane, y is equals to of 9 minus x. Till this point, each and everything must be clear to most of us. Yes. Anyways, may I know how we deal with the problem related to the bivariate independent variable, and when we deal with those sort of problem over the concept of maximum and minimum. See what we do. The important factors has to be calculated at very beginning. What are they? P is partial differentiation of the function f with respect to the x. Similarly, we calculate q. The q is called the partial differentiation of f with respect to the y. Here goes r. There is a partial differentiation of f along with the x as well as y, along with the x as well as y. Once we are done with this, we move ahead with the next factor. We call it S factor, which is nothing but the partial differentiation of f with respect to the x two times. Just a minute, there was a mistake over here. There was a mistake over here. What we can do, anyways, let me rub this out. Let me rub this out. So whenever we discuss about the R, that is partial differentiation of, that is a partial differentiation of f twice with respect to the x. Similarly, if we'll discuss about the s, it's a partial differentiation of f with respect to the x as well as y together. And similarly, the last factor used to be t, which is a partial differentiation of f with respect to the y twice, with respect to the y twice. Yes. Till this point, each and everything must be clear to all of us. And many of the times, even the p has been referred as, f of x. What does that mean by the f of x? That means the f got differentiated once with respect to the x partially. Similarly, the q is also being referred as f of y. R has been referred as f of xx. In few of the books, it's also been referred as f of x square. Similarly, s is being referred as f of xy, or you can also write f of yx. Yes, the sequence can be changed. First, you can take the partial differentiation of f with respect to the x, or alternatively, you can take the partial differentiation of f with respect to the y. Similarly, the t is nothing but f of yy, as we have been writing for the f of xx, or here I can write f of y square. See, deliberately I am indicating all of the possible notations for the p, q, r, s and t, because many of the times I have seen in GATE examination, rather using this notation, they go ahead with this notation, and I have seen many of the times the student used to be in big trouble because they have not been well acquainted with this notation. Could you understand what I am saying? So yes, it's the problem of concept of maximum and minima, because at very beginning the two acquainted word has been clearly written over this complete problem, and that is nothing but the concept of the maximum and minima. How many number of independent variables are getting involved? Clearly it has been mentioned the f is going to be a dependent variable which has been depending over the two independent variables, which is nothing but the x and y. Even they could have not been written this note, then also by watching this particular expression you could have figured it out. It has been the function of two independent variables x and y. That means we had to apply the concept of the maxima and minima with the two variable independent functions. Yes. Now, see, whenever we discuss about the maximum or the minimum worth of the bivariate function f of xy, definitely I should have a certain range. The range also has been clearly specified within the problem, that the maximum or minimum value has to be calculated within the range of x is equals to 0. What does it mean by the x is equals to 0? That's the y-axis. Y is equals to 0, that's the x-axis. And similarly goes another straight line, y is equals to of 9 minus x. Yes. Now, if we'll recall what used to be the procedure for calculating the concept of the calculation of the maximum minima, we calculate the 5 important factors. What are they? P, Q, R, S and T. They are partial differentiation of the given bivariate function with respect to the first independent variable, second independent variable, first independent variable twice, with respect to the first as well as second independent variable, and similarly the last is gonna be with respect to the second independent variable twice. Yes. Could you understand what exactly I wanted to say? See, deliberately I have wrote this thing into the great detail because many of the times you may have the situation, instead the x and y, you may have a function, bivariate function, where the independent variables are in a form of a, b, maybe in a form of l and m. So there what the changes you will be having, instead the x, there the first differentiation would take place in terms of a, then b, then a square, then ab, then b square. Yes. So far I have not seen this sort of problem which have come into the GATE examination. So far I have not seen this sort of problem have come into the ESE or ISRO examination, but yes, they may design this sort of problem. So you had to be bit cautious about this formula and all. You should not just mug up this formula, you should have its practical validity. Yes. So what I would be doing over here, let me copy this problem and bring it to the next working board where I would be smashing this problem out completely. Yes, again goes this first question of the day. My dear friends, it has been clearly said the 5 different number of factors has to be calculated. We start with P, then goes to Q, then goes to R, S and T. So why don't we start with that only? So what I would be doing, let me write solution once again. I would be starting with the first step. Anyways, let me write the bullet marks which will look good. Yes. So at very beginning what I was saying, why don't we start calculating the value of P, Q, R, S and T. P, here goes Q, here goes R, then here goes S and here goes T. Tell me what would be the worth of P. Anyways, the P has been clearly defined. The P is nothing but the partial differentiation of the function f with respect to the x. That means partially the differentiation has to be taken place of 2 plus 2x plus 2y minus of x square minus of y square with respect to the x. Being a 2 as a constant, definitely it would become 0. The 2x differentiation is simply going to be 2. 2y differentiation is going to be 0. Why? Because the y has to be treated as a constant if the partial differentiation has to be taken place with respect to the x. That means instead the x, all of the rest of the variable would be treated as constant. It becomes 0, it becomes minus of 2x, it becomes 0. So precisely if you wanted to write the value of P, so simply I can write the value of P over here. What is that? The value of P is nothing but 2 plus of 2x. Yes, everybody would agree on that. And now if I'll take the partial differentiation of it, so simply here it becomes 2, here it becomes 2, here it becomes minus of 2x. Agreed? Now it's a time to calculate the value of Q. What does it mean by the value of Q? This bivariate function has to be partially differentiated with respect to the y. So definitely this factor becomes 0, this factor becomes 0. Here you will be getting 2 and again you will be getting minus of 2y. Yes. Once you are done with Q, you had to move forward and you had to calculate the value of R. What does that mean by the R? The bivariate function has to be differentiated twice with respect to the x now. See my dear friends, this becomes 0 and as the degree of this term is 1, so obviously twice differentiation with respect to the x would lead the value as 0. It becomes 0, it becomes 0. The factor which would be left out is simply going to be, first time it's going to be minus of 2x and second time if we'll take the differentiation, it would be leading just minus 2. It would be leading just minus 2. Agreed? Now similarly, here goes S. May I know what would be the S over here? The S is going to be the partial differentiation of the bivariate function with respect to the x then y, or maybe with respect to the y then x. Anyways, the P is already been calculated now. So what you can do? The P is nothing but the partial differentiation of f with respect to the x. So now the differentiation has to be taken place with respect to the y. And as you can see, the P is completely independent from y. The value of s which would be leading is simply going to be 0. And the same case goes with the Q. The Q can be partially differentiated with respect to the x, and there also you will be getting the same outcome. Yes. And then last component which comes out to be P, Q, R, S and T. What is the T over here? The T is nothing but the partial differentiation of f with respect to the y twice. My dear friends, once the partial differentiation of f is already being taken place with respect to the y, why don't we take another differentiation? So the result which would be leading in my hand is simply going to be minus 2. It's simply going to be minus 2. Yes? Yes, my dear friends? Now, what I would be doing, now I had to search for the stationary point. What does that mean by the stationary point? See, the stationary point, the name itself is self-explanatory. The stationary point where everything becomes thumbs. Agreed? That means either the function was keep increasing, then for the moment of time when the stationary point comes in a picture, now neither it would be increasing continuously, neither it would be decreasing continuously, or I can say the slope becomes 0. Anyways, how will I calculate the stationary point? My dear friends, it has been a 3D structure. You can take this as a x-axis, you can take this as a y-axis, and now the f of x, y has been the function of x and y together. That means the z is going to change with respect to the x and y. So now if you really wanted to locate the stationary point, now what you had to do? At a moment where the slope have become 0, you had to take its rate of change with respect to the x as well as with respect to the y, and you yourself would be able to judge if the slope is 0 over here, no, so the slope of the function with respect to the x as well as with respect to the y would become 0, and that is what I am doing. Whenever we search for the stationary point with a bivariate function, what I used to take the value of P, which is the partial differentiation of the function with respect to the x, and similarly Q, which is the partial differentiation of the function with respect to the y, becomes 0. That means here becomes 2 minus of 2x has to get compared with 0, 2 minus of 2y has to get compared with 0. So the two outcome which we are getting out of this, 2 minus of 2x is equals to 0, 2 minus of 2y is equals to 0. obviously we have got the two distinct linear equation, and once I'll be solving, the result which I am getting in my hand is simply going to be 2 goes towards right hand side becomes minus 2, minus 2, minus 2 goes out, the x becomes 1, and similarly y becomes 1. What does that mean by the x is equals to 1, y is equals to 1? They are the stationary point. The stationary point are the point where the slope over the bivariate function f of xy becomes 0. In 3D, if you would like to visualize this, I may give you a bit example. See what is happening over here. Let's take for the time being it's my y axis, and let's take this is what my x axis, and let's take it's my z axis. Z is a function of x and y, or I may call it f axis, where the f is a function of x and y. F is a function of x and y. Obviously, you would be making a 3D structure over here. So why don't we draw a 3D structure? You may have a 3D structure somewhere here. And now around this point, you yourself would be able to understand, sir, this point is no more slopy. Here, if you'll say, obviously, if you're moving towards the right hand side, the magnitude of f of xy is keep increasing. And similarly, if you take the reference of this point, and if you're moving towards a positive value of y, definitely the value of f of xy is keep decreasing. But at least at a certain moment of point over this plane, you yourself would be feel, sir, no, I do not find any slope over here. That means if I go towards the right hand side, towards the left hand side, towards the outside or towards the inside, almost the magnitude remains same. Magnitude remains same. May I know which point it is? This point is nothing but the stationary point. This point is nothing but the stationary point. Now the next thing comes in mind, sir, how will I calculate, how will I evaluate the stationary point with the help of mathematical tool, my dear friends? That is what I am saying. No, this point, let's take this point in 3D structure is like this. So if you take the slope with respect to the x, if you take the slope with respect to the y, in both of the cases the slope has to be 0, and that is what I have been doing over here. So you yourself would be able to easily understand. This is the point of stationary. I may write it x is equals to 1 and y is equals to 1. X is equals to 1 and y is equals to 1. The next thing comes in my mind, okay sir, the stationary point have come to the 1, 1. But now the stationary point may come because of 3 different factors. You may have extremas. Within the extrema, you may form maxima or minima, or even you may form a saddle point. What does it mean by the saddle point? That means in a certain direction, the magnitude is decreasing. In a certain direction, the magnitude is increasing. The example is already been given earlier. If you take an example of seat which used to be placed over the horse while horse riding. Let's take here, I have got a horse, and here I have got a sheet over the horse riding. And now you yourself would be able to judge. See, if I am moving in this direction, or you take the example like this, if I am moving in this direction, the magnitude is increasing. If I am going in this direction, the magnitude is increasing. But if I am going in this direction, the magnitude is decreasing. Agreed? So here goes the saddle point. Yes. So that is what I am saying. Although the maxima has been formed over 1, 1, minima has been formed over 1, 1, either the saddle point has been formed over 1, 1. In all of three cases, 1, 1 would be the stationary point. Could you understand how this process is going on, my dear friends? See, the complete methodology of this series itself is CTQ. That means I had to deliver the concept through the questions. That is why I am going to take few of the important questions. Although many of the students would be able to smash this problem within the 2 minutes, but the student who are able to smash this problem within the 2 minutes, they themselves do not exactly know what they are doing. That is why I have taken such a huge amount of time while solving this problem. First go ahead with the PQRST, then go ahead with the calculation of what stationary point. Now the next thing comes, this stationary point have been formed because of maxima, minima, in totality extrema, or because of saddle point. How we check that? I used to perform RT minus of S square test. What I do? I perform the RT minus of S square test. So why don't we write it? RT minus of S square test. Where it has to get performed? It has to get performed over the stationary point. May I know what it is? It's a 1, 1. Yes. My dear friends, the value of R has been minus 2. The value of T, the T has been minus 2. The value of S has been 0. Although for the higher degree polynomial, we used to have a RT minus of S square as a function of x and y. And when we have RT minus of S square as a function of x and y, instead the x 1 has to be fed in, and similarly instead the y, the 1 has to be fed in. Many of the times I have seen the student used to have one doubt, sir, although we get 1 comma 1, which are the values of x and y, but most of the time we do not find where I need to feed the value of x and y. So what's the use of this problem, my dear friends? This problem has the degree of 2. Once you'll see the degree of x, which is 2, and once you'll see the degree of y, which is 2. If you have the degree of 3, no, definitely the RT minus of s square would become the function of x and y, and there precisely you had to feed the value of x as 1 and the value of y as 1. Agree? Now, anyways, once you'll calculate this, the value is gonna be simply 4. Value is simply gonna be 4. Now, what I would be doing next? So, most of us must be well acquainted with RT minus of s square test. See, in terms of their sign, I am not talking about their magnitude and all. In terms of their sign, obviously we can bifurcate in 3 parts. First, if RT minus of s square at the stationary point has been found positive, has been found negative, or has been found 0. My dear friends, whenever at a stationary point RT minus of s square is found positive, there used to be the formation of extrema. The extrema could be the form of minima or maxima. That's a different story together, but yes, it would be forming an extrema. Yes, whenever the negative has been found over the critical point, keep in mind here we call it saddle point, neither the maxima nor minima. And if the RT minus of s square is found to be 0, keep in mind the further investigation is required. FIR has to be done. It's not that FIR what we do over the police station, but yes, further investigation is required. Anyways, once you will take the reference of this problem, you yourself would be able to understand the value of RT minus of s square is positive. So obviously the category of the problem would fall under the extrema. Extrema, that means extrema is being formed. Extrema is being formed at 1 comma 1. Yes. Yes, no? So now the next thing goes like, now within the extrema, now you have to check it out whether the maxima has been formed or whether the minima has been formed. So again, I had to conduct the next test. If RT minus of s square is found to be positive, now you have to investigate the sign of R. Sign of R. If R is found to be negative, that means at the stationary point the maxima has been framed, and if R is being found positive, minima has been framed. Minima has been framed. Yes. Anyways, you had to feed the value of x over here. But as far as this problem is concerned, no, R is simple a constant value itself. So obviously it is falling under this category, where the value of R is negative over the stationary point. What does that mean of it? That means the point of stationary or the stationary point is stationary point 1 comma 1 is the point of maxima. Yes. Till this moment of point, each and everything must be clear to all of us. So what would be the next step? I would be taking the reference of this. I would be feeding x is equals to 1, y is equals to 1, and I'll get the best most answer. Yes. So here goes the further calculation. My dear friends, what's the conclusion we have got it? X comma y 1 comma 1 is a point of maxima, and obviously it's a unique maxima or global maxima. Because apart from 1 comma 1 you did not have any stationary point, and apart from 1 comma 1 if you did not have any stationary point, definitely you would not be having any extremas, maybe maxima, minima or the saddle points. Yes, agreed what I am saying? So what I would be doing over here, see what they have been seeking for. They have been seeking for the absolute maximum or minimum. Anyways, I cannot decide its minimum most value, because here we have got it a maximum or the global maxima, and as you will be increasing the value of x and y, or if you will be moving away from this point, definitely the magnitude would be continuously decreasing. So basically I had to focus over the maxima alone, and yes, you would be getting the maximum most value at 1 comma 1, so that you had to feed over here. So f of xy is clearly known to me, would have its maximum value, but precisely when the x has to be fed as 1, y has to be fed as 1. Yes. So let me calculate this value. So here it goes, 2 would remain 2, plus of 2 into x, x is 1. Here goes 2 of y, the y is 1, minus 1 is square, minus of 1 is square. You had to get the answer out of this. You had to get the answer out of this. So here the result what we get, 2 plus 2, that's a 4, plus 2, that's a 6. Anyways, this 2 and this 2 would go out, and the result which we are getting is simply going to be 4. It's simply going to be 4. It's simply going to be 4. Agreed? So the structure is sort of this, what I am saying. In 3D, the structure is sort of this. Exactly, I cannot say this is the actual structure, but in 3D, the structure is like this. We used to have coconut top, no? Top. So if you are keeping the coconut top towards downside, that means I can say lower facing concave. Lower facing concave, you would be having the structure sort of this. And here goes, this has to be drawn over the 3D plane, no? Or 3D space. Here goes, so here the point would be 1 comma 1, and the maximum value has been found as 4. At 1 comma 1, the maximum worth of the function f of xy was found to be 4. So what's going to be the best most answer? Yes, the C is going to be the best most answer. Best most answer. Now the people have started asking few of the questions. What if r is 0? Anyways, I can take that problem also, but I had to design the problem and I had to explain further. So probably this would not be the agenda of today's video, but yes, in future I may take that situation also. Could you understand what I am saying? See what is happening over here. Many of the students would be thinking, sir, why we are spending so much amount of time over the same problem itself. My dear friends, the concept behind this complete series is nothing but the concept to the question. That means we had to extract the concept and we had to prepare ourselves like taking the reference of this single problem, I must be able to solve the remaining problem. Yes, this was the exact case. This was the exact case. Agreed? Agreed what I wanted to say? So now it's time to move on. And yes, we would be moving into the second question. And probably the student who are well acquainted with the linear algebra and the important process which we use over the linear algebra, they would be able to smash this problem out. Again, this problem have come in engineering services examination year of 2020, common to all people. So let me crop this problem and bring it to the working board, and I would try to solve the problem there itself. Tell me what would be the best most answer for the second question of the day. Tell me what would be the best most answer. Anyways, let me read the problem carefully first. Here goes the solution. See what the problem states. For the matrix A is equals to 1, 4, 2, 3, the expression a to the power of 5 minus 4 times of a to the power of 4 minus of 7 a to the power of 3 plus of 11 a to the power of 2 minus of a minus of 10 of I is equivalent to the 4 different options were attached along with this problem. The first option goes like a to the power of 2 plus of a plus of 5i. The B goes like a plus 5i, the C is a square plus of 5i, the D is a square plus of 2a plus of 6i. May I know which approach has to be used and what would be the best most answer? Anyways, before starting this problem, I would like to ask one thing. If the matrix A is known, what I am saying, just try to understand. So irrespective of knowing the nature of or the order of matrix A, would you be able to say it's a square, a cube, a to the power of 4, a to the power of n would be possible? I wanted to ask from each one of you, if you have any random matrix A, whether you can get its value of a square, a cube, a4 without knowing the order of that matrix, or this matrix A should have a little bit criteria to found in the form of a square, a cube, a to the power of 4. My dear friends, I have seen many of the times the student used to have doubt this a square, a cube, a to the power of 4, or I can say a to the power of n, where the n is a natural number and where the n is greater than 1. My dear friends, that's possible only if the matrix A is a square matrix. Would you agree on it? Would you agree on it or not? Just wanted to ask from each one of you. My dear friends, whenever you say a square, no, it's not the simple algebra where I used to take square, I just multiply them. No, here there would be the multiplication of the matrix a twice. That means you would be having a getting multiplied with the a again. And my dear friends, their multiplication would not be true until and unless their number of column in the first matrix is not matching with the number of rows in the second matrix. And as you can see very well, both of them are the similar matrix. In that case, the number of rows and number of columns can be matched only and only if they are square matrix. If they are square matrix. Could you understand what exactly I wanted to communicate? I have seen many of the times the student used to have one doubt, sir. Okay, sir, a square, a to the power of 3, that's nothing but the squaring of the matrix. A to the power of 3 is nothing but the cubing of the matrix. Obviously, it must be possible for all of the varieties of the matrix. No, it's possible only and only for the square matrix. It is only possible for the square matrix, and the same concept we use repeatedly when we deal with the eigenvalues as well as eigenvector. Could you understand what I am saying? So in future, whenever you are writing a square, a cube, a3, a4, a5, by default one thing must be there in your mind. You have been dealing with a square matrix, otherwise their multiplication would not be possible at all. Although I have been dealing with the a square, even in case of a cube, that means the three matrices have got multiplied together, and their multiplication could have been valid multiplication only and only if the number of column in the first matrix has to be matched with the number of rows in the second matrix. By default, it has to be a square matrix. Yes. No, you can't say like, sir, I have got a 1 cross 2 and 2 cross 1 and their multiplication is possible. My dear friend, you have been dealing with the same matrix. That means you cannot have this sequence. No, you cannot have that sequence. Agree? The same thing goes with, you can see very well, we have been allocated with a square matrix, and then only they are writing a polynomial with the degree of 5. And now they wanted to deduce it to the parabolic polynomial. Yes, here it is a parabolic polynomial, and here it is a linear polynomial. How may I know how we deduce it? Obviously, we use the concept of the Cayley-Hamilton. Anyways, may I recall what used to be said by the Cayley-Hamilton? What used to be the statement given by the Cayley-Hamilton? All of these square matrix satisfies it's on. The on word is very important word. It should not be the case that you have calculated the characteristic equation for a given matrix, and now you have been taking the reference of another matrix and you just wanted to satisfy them. No, what I am saying, if you have got a square matrix, you can get its characteristic equation, and within the characteristic equation definitely you would be having the presence of lambda, which we call it eigenvalues. Now that eigenvalues can be replaced with the matrix A itself, and still it would be satisfying the given equation. So what I am saying, all of these square matrix satisfies its own characteristic equation. Yes. May I know what used to be the characteristic equation? The characteristic equation used to be the function of lambda, which is getting compared with 0. Yes. So as per the Cayley-Hamilton, what it tries to say, now the function would remain as it is, the lambda can be replaced with a, and still the above equation would be satisfied. Although in first look it looks okay, sir, nothing great, but yes, it is a great outcome, my dear friends. Here you have been dealing with a simple equation, where here you have been dealing with the matrix equation. Why? Because lambda was a simple number, could be real, positive, negative, repeated, anything, but that was a number. But here the a which we have been playing, or where the lambda has been replaced with the a, it is a matrix equation. Such a huge outcome has come out. Agreed what I am saying? So my basic intention would be the calculation of the simple characteristic equation, and once we are done with the characteristic equation, we'll move forward and the lambda has to get replaced with a, and we'll see how we can deduce this problem into the parabolic form or the linear form. So here goes the calculation of characteristic equation. the calculation of characteristic equation. How the characteristic equation is being defined? Simply defined as A minus of lambda I used to take its determinant and has to get compared with 0. Has to get compared with 0. Sir, all of these square matrix satisfied its own characteristic equation? Obviously, yes. Agree? So now the matrix A is clearly known to me. The lambda is nothing but the eigenvalues, we will see afterwards. And what is the I over here? The I is the identity matrix. And if they had to get subtracted, the I which we had to select has to be in order of 2 cross 2. So obviously, if you want, I can expand a bit. So here goes A, which is 1, 4, 2, 3, 2, 3. Here goes lambda. The lambda has to get multiplied with the identity matrix with the order of 2 cross 2. My dear friends, which you have seen earlier, whenever a certain constant gets multiplied with a matrix, that constant has to get multiplied with the each and individual elements within the matrix. How many elements we had? The 4 elements we had. Here I would be having 1, 0, 0, 1. Now the lambda has to get multiplied with each and individual component. So the result which would be coming in my hand is simply going to be lambda 0, 0, lambda. I would be taking its determinant and has to get compared with 0. Yes. And now you can see very well both of them have been in order of 2 cross 2. Obviously their addition as well as subtraction is a valid approach. So here it goes 1 minus of lambda, here it goes 4, here it goes 2, here it goes 3 minus lambda. And yes, I need to take their determinant, and once we are done with the determinant, the characteristic equation would be in front of you, So most of us must be well acquainted with the calculation of the determinant. The multiplication of the 1 minus lambda would take place with the 3 minus lambda minus of 2 into 4, that is a 4, 8. So anyways, 1, 3, that would be 3, 1 minus of lambda, that would be minus lambda. So the result what we are getting out of this, no, minus lambda and lambda would result plus of lambda square. Similarly, minus of 3 lambda minus of lambda would result minus of 4 lambda, minus of 4 lambda, yes. And similarly, 1 and 3 would result 3 itself, and here it goes minus of 8 is equals to 0, minus of 8 is equals to 0, agreed? No? If any mistake you are finding, you can just put it over here itself, but probably each and everything is fine till this moment of mind, So yes, the like term I can consolidate minus 4 of lambda, the 3 and 8 are the like term, and once they will be subtracted, the factor which should be left out is simply going to be minus 5 is equals to 0. Minus 5 is equals to 0. Anyways, let me copy this problem out for the next, and yes, this outcome would also be recalled. Here goes the problem. Just a minute. Here goes the outcome. Tell me what's the answer we are getting. So the student already have gone through this sort of calculation again and again when we have discussed within the engineering mathematics of the gate. So obviously they must be able to calculate this out. Tell me what would be the best most answer. I would be giving around 1 minute to find the exact most answer for this given problem. Tell me what would be the best most answer for this given problem. See what I would be doing. Now the lambda has to be fed as A as per the Kelly-Hamilton, and yes, it would be satisfying it. And here it becomes, just a minute, I can check it out once again, minus of 4 lambda it was, no, minus of 4 lambda, and yes, minus of 3, minus of 3, minus of 5 is equals to of 0. Anyways, as I have been dealing with the matrix, so obviously the minus 5 cannot be kept bare, it has to come along with the identity matrix of I. My dear friends, we had to reduce this problem into a lower form of the polynomial. I can take the help of this outcome, which has been a well proven outcome with the help of Kelly-Hamilton. So we have started getting, no my dear friends, I need not to calculate what I am saying, I need not to calculate its root. Anyways, I would be using the formula which has the degree of 5, a to the power of 5 minus 4 a to the power of 3 minus of 7 a to the power of 3. Here goes 11 of a square. Here goes minus of a. Here comes minus of 10i. Here comes minus of 10i. With the help of this expression, I would try to deduce this higher power of the degree. See, my dear friends, this a to the power of 2 can be connected with the a to the power of 5 just by multiplying a to the power of 3. Not only that, even minus of 4a can be connected with the minus 4a to the power of 3 by just multiplying a to the power of what? 2. Just a minute. Any mistake? Yes, the mistake was there. Here it was a to the power of 4 now. A to the power of 4. Yes. So let me start doing that analysis. So what I would be doing over here, you can extract a to the power of 3 out. It becomes a to the power of 2. You can extract a to the power of 3 out. Obviously, it would become minus of 4a. But here there is a certain messy-pun. Here I wanted to have a minus 5, but there I have got minus of 7. So obviously, I can change this problem a bit. And minus of 7 could have been written as minus of 5 times of a cube, minus of 2 times of a cube. Here goes 11 times of a square minus of a, minus of 10 times of I, minus of 10 times of I. What is the advantage we are getting? Obviously, the advantage is in front of you. I can get a cube out. The factor which should be left out is simply going to be a square minus of 4a minus of 5i, minus of 5i. Yes, minus of 5i. Anyways, I would be keeping this factor as it is. In future, even I will try to deduce into the lower form of the polynomial. But yes, for the time being, I would be keeping as it is. Yes. See what is happening. A square minus of 4a minus of 5i has been a null matrix. It's not 0, no. Has been a null matrix. May I know what would be the order of the null matrix? My dear friends, a square. What would be the order of a square? The order of the a square would be same as the order of a. Similarly, if you take a to the power of 3, a to the power of 4, always the order would remain as it is. So that means in future you are getting a null matrix with the order of 2 cross 2. Anyways, when the null matrix is getting multiplied with the a to the power of 3, again you would form a null matrix. And what would be the order of that null matrix? The null matrix order would be in order of 2 cross 2. Anyways, you can keep as it is as 0. But I have seen many of the times when the people write 0 or 1, no, they forget each and everything that they are dealing with a matrix, and in future even this conclusion may have the huge impact. Yes. Now I would do little bit more calculation. My dear friends, see, minus 2 times of a cube. What I would be doing over here, just try to understand in this way. What would be the next calculation which I must be doing now? Now the a to the power of 5 has to get connected with the minus 2 times of a to the power of 3. Tell me, how will you process further? And yes, this component has to go along with the a to the power of 5. If you are writing like a to the power of 3 minus of 3 times of a to the power of 3, what is happening? You could not reduce its degree of polynomial. So for the reducing of the degree of the polynomial, this minus 2 times of a cube has to go along with the a to the power of 5 once. Tell me, how will you calculate this? So my agenda would be deducing this into the next format. Tell me, how you will be doing it? This 1 has to get connected with the minus 2. Tell me, what would be your approach? See, again, here it's a square, here that is minus of 2a square. So what I would be doing, my dear friends, I want minus 2 to the power of a to the power of 3. What I am saying, minus 2 into a to the power of 3. So once you will be multiplying minus 2, it gets multiplied with the a square, and again the a gets multiplied. So the factor which should be left out is simply going to be, so what I would be doing, I would be multiplying with minus 2 times of a over here. And once we multiply them together, so the result which we are getting now, the first component have been very same as the required one. Similarly, it becomes plus of 8, a and a gets multiplied, it becomes a square. And similarly, minus 2a gets multiplied with the minus 5, that becomes plus of 10i. Yes, my dear friends. Anyways, the remaining component was a minus 2 times of a cube plus of 11a square minus of a minus of 10i. Among them, the minus 2 times of a cube has already been ruled out, or it has already been extracted out. But yes, instead the 11a square, I could only bring 8a square out. That means 3 times of a square should also be coming more. Yes. Next, instead the minus a, you have brought 10 times of I, that has to get compensated with the worth of minus 11 times of A, minus 11 times of A. Why? Because, just a minute, A is not there. Just a minute. Here the minus 2, okay, it's a A only, no? It's a A only. It's a A only. Yes. So what I am saying, this 10 times of A has to get subtracted with this, so it becomes minus of 11A, minus of 11A. And now next thing, I did not have minus of 10I, so obviously minus of 10I would remain as it is. Minus of 10I would remain as it is. Tell me what would be the best most answer? What would be the best most answer? Could you understand? This sort of ambiguous problem do not come repeatedly into the GATE examination, but yes, this sort of problem do come into the ESE. See, with the help of A square minus of 4A minus of 5I is equals to 0, although we had the polynomial of the matrix with the degree of 5, what I did? I started deducing it. At very beginning, a to the power of 5, when I am taking a to the power of 3 out, the factor has been the same factor when the worth is simply 0, where the A square minus of 4A minus of 5A is simply 0. But the factor which has been remained after this, now it is not coming into the same form. So we had to apply a certain brain and bring it to the same form. So what I would be doing, the A square has to get connected with the minus 2 times of A cube. So obviously the minus 2 times of A has to get multiplied. So it becomes minus 2 times of A cube. That's very fine. And here it becomes plus 8 times of, just a minute, any mistake has been taken place? Yes, here it becomes 8 times of A square and here it becomes 10 times of A. But as far as the component which was left earlier, minus 2A cube as it is, but here I wanted to have a 11 times of A square, whereas I could consolidate only 8A square. So obviously the remaining component has to come over here. Once we are done with this, we had to focus over here. Already I have brought plus 10 times of A, whereas the actual worth of this polynomial is nothing but the minus of A, that has to be compensated by subtracting 11, and similarly it goes like this. Agreed? No? So what would be the next calculation which we had to carry out? See, if you want, I can do the calculation once again. Minus 2A can be brought it out. Once the minus 2A is brought it out, the factor which should be left out is simply going to be A square minus of 4A minus of 5I, which is again 0, So the factor which you would be left with, and even it can be further deduced. Yes, even it can be further deduced, and the best most answer which you will be getting at the end is going to be A plus of 5I. The best most answer which you will be getting at the end is going to be A plus 5I. Again you can reduce and you can multiply the 3. Yes, if the 3 is getting multiplied, it would become 3A square minus of 12A minus of 15I. Yes, why don't we bring out AV? So here it becomes 3A square minus of 12A minus of 15I. Yes. Now you yourself would be able to understand, my dear friends, although I have taken the 3A square minus of 12A minus of 15I just because I wanted to make this term as 0, but I had to bring back this structure which was there in earlier row. So what I would be doing over here, 3A square would be as it is. Now instead the minus 12, I had to make it minus 11, so obviously the A would get added, and similarly 5I would get added. This is 0, and the answer which we are getting is nothing but the option B, A plus of 5I. Yes, one of the well-designed problem, most designed problem I should say, not the well-designed even. Yes, most designed problem. Tell me, how will you approach this problem? Such an intensely designed problem. This problem have come in engineering services examination, ESE, in technical paper of electrical. Anyways, probably I would not be taking this problem in today's video, but still I would try to analyze and I will try to have a little bit analysis over this problem. Tell me, how will you calculate this problem? The mean deviation about the mean mu of a normal distribution is nearly. Anyways, whenever you discuss about the mean, basically you are focusing over the expectation. No, Manish Kumar is saying, sir, it takes hell amount of time. How we can shrink this problem a bit? My dear friends, probably it does not take that much amount of time. Anyways, it has got rubbed out. See what is happening over here. Probably you must be knowing how to calculate the characteristic equation with the help of trace and determinant. Yes, that format must be known to you. The Gurupal sir has already been taught that. And usually whenever we release the answer key, there also we used to have the second method where straight away the characteristic equation can be calculated with the help of the trace of the given matrix and with the help of determinant of the given matrix. So what I am saying, once you are visualizing or once you are watching the matrix A itself, in the next step you can get its characteristic equation. Yes. And once you are done with this characteristic equation, anyways, what would happen? You would be having a copy in front of you, and you would be visualizing a very high degree of polynomial. So start doing one thing. The degree of polynomial can be shrinked into the form of linear or maybe parabolic equation. So start hiding few of the component, and once you will be doing few of the simplification, end of the day you would be reaching into the final conclusion. Agreed what I am saying? Although this much must have been taken as such a huge time, but once you will be sitting into the engineering services examination with the help of the concept of trace and determinant, in the one step you would be able to get the value of characteristic equation, and relating the characteristic equation with the given equation, you would be able to deduce that equation probably in 2 or 3 number of steps. And yes, whenever you are doing the calculation, here one thing I should say, I have seen one thing. Whenever you trap into the any calculation sort of problem, so you can assume in this way, that means you have chosen the wrong path, because either you take the reference of the gate or either you take the reference of ESE. They try to design the problem in such a way that it used to be a very less calculative or very less complex in terms of calculation, I am saying. But many of the times what happens, the student do not take that same route, the route where the teacher has been designing that problem. So what happens, they used to calculate that problem again and again and again, so many number of steps they used to spend. So I would say, if you have gone into that loop, probably where the answer is not supposed to come, stop there and try to go into the next problem. See what would happen, what I am saying, at very beginning, in starting 4 to 5 number of steps, you yourself would be able to visualize whether you are going into the right path or not. And if after 9 to 10 number of steps still you are a bit confused whether you have taken the same correct steps or not, so I would say only one thing, stop there itself. Rethink about the problem whether it has got a different step or not, or otherwise jump into the next problem, because specifically in ESE you do not have that much amount of time. When I was discussing about the pattern of the ESE examination, in first set paper 1 you have got only 2 hours, and that is very precious. So I would just request to each one of you, whenever you are sitting in ESE, ISRO or BRC, the time is a major concern, and whenever you sit into the gate examination, probably the time is not that a big factor. Yes, anyways, the next question which I wanted to discuss in today's class, may I know what would be the approach to solve this problem out? It is a very well designed problem, it is. Anyways, we will take this problem in tomorrow's video. The time of the class would always be same from 9 to 10 p.m. And once we are done with the previous year questions which have come into the engineering services examination and ISRO, I would again be continuing the same format of the video which I was taking earlier, where I was discussing about the vector calculus, random variable, random process and complex variable. Okay then, this is all for the today's video. We will be meeting with the same series of the video at 9 p.m. tomorrow. Till then, bye-bye, take care, thank you, thanks a lot.